Okay, let's take a look at number 4 from 5A. Okay, so this is rewriting equations so it has the form x equals. So a lot of these are just going to involve various exponent type rules here. That's what I'm guessing looking at this thing anyway. So, okay, so x to the fifth equals a cubed. So if we want to isolate x, we got to get rid of that fifth power. So if I rewrite this thing as x to the fifth and raise it to the 1/5, then I got to raise this side to the 1/5. And if you remember, if I raise a power and like a power term to another power, then that's the same thing as multiplying them. So this is going to be just x right here. In fact, that's the whole point of raising it to the 1/5. So it becomes x to the first. So it's just x equals a to the 3/5. So there's the first one. So for b, I've got a to the 1/5. Or sorry, x to the 1/5 now equals a cubed. So instead of raising it to the 1/5 like I did in the previous problem, I'm going to raise them both to the fifth. And this will turn into x, and this will turn into a to the 15th, because it's a cubed times a cubed times a cubed 5 times, so there's 15 a's there. Okay, part C, we got 1 plus x to the 15.6 equals 2.0. That's weird. Okay, so we're going to raise both of these to the 1 over 15.6. Right? Which is also the same thing as the 15.6th root of 2, although I have no idea what that really means. So I'm not going to worry about it too much. I would say don't bother with roots for that kind of stuff. It's like a square root or cubic root, then you can write those out. But beyond that, usually you just use the exponents. Okay, so these guys kind of cancel each other out and turn into 1. We got 1 plus x equals that 2.0 to the 1 over 15.6. And then I got to subtract 1, so it's negative 1 plus the 2.0 to the 1 over 15.6. That is a weird looking, I don't know where I got that problem from. I want to see what that equals. Negative 1 plus 2.0 to the 1 divided by 15.6. That can't be very big at all. So let's see. All right, so it's about 0.045. Okay, and then for D, we've got x to the negative 2 equals a. So in order, that's the same as 1 over x squared equals a. So we could do this a couple of ways. One method would be raise both sides to the negative half. Whoops. That's weird. Okay, a to the negative half. So then x equals a to the negative 1/2, which is really 1 over a to the half, which is really 1 over root a. You could write it any of those ways are fine. The other method would be if you multiply the x squared over, you get 1 equals ax squared, and then you divide the a, so you get 1 over a equals x squared, and then you take your square root. Right? Okay. Oh, I just realized something. We need to plus or minus this. And this. And this. And this. And this. And here's why. Right here, we're essentially taking a square root of both sides. What you're really doing is you're taking 1 over the square root of both sides. So you, as soon as you do the square root of both sides, that 1/2 power, you have to use the plus minuses. So that's how we end up with that plus minus there. Okay. All right. I think that's it for number 4. Yes.